Hello everyone. We are now going to talk about another type of measurement associated with the standard deviation that we just learned about. It's called the z-scores, right? Now, the z-scores tell us how far a particular observation is from the mean. All right, so that's what we are going to learn about in more detail in this lecture, and we will also learn how to calculate the value of a z-score. So as part of this lecture, we will first go into understanding what z-score means, and then we will learn how to calculate a z-score given the mean and the standard deviation of a data set. Let's go over the definition of a z-score and also try to understand what actually it is. A z-score, also called standard scores, are measures that indicate how far a particular data point or observation is from the mean in units standard deviation. So the z-score would be a value between -3 to +3 normally. It could be a value outside this range, but usually z-score values fall between -3 and +3. And it's derived from three pieces of data. One is the population mean, denoted by mu. Then we need the population standard deviation, denoted by the Greek letter sigma, and then a particular observation. A particular observation also called or denoted by the letter X. All right. So using these three variables, we can find a value of Z. Now, what is Z in layman's terms? The Z value is really the position. It gives us the position of a particular x value relative to the center position of the curve. Now keep in mind, in a normal symmetric curve, the mean will always be located at the center point. It will be aligned to the peak or position of the curve, right? So the mean will always be located at the center, and that represents the center point. And the z-scores give us the distance of an observation, relative to the center of the curve. All right. So with this understanding, let's go into what the formula of the z value or the z-score is. Again, keep in mind we will need these three parameters to find a z-score: the population mean, the population standard deviation, and the value of a particular observation represented by the letter X. Here we are presented with the formula to find the value of a z-score. Three pieces of information are needed in order to calculate the z value. As you will see in the formula itself, we need the mean, a value for the mean, and we always use the population parameters, population measures when calculating the z-score. So you will see the letter mu, the notation mu instead of x bar for the mean. The specific observation denoted by the letter X, whose distance we are trying to find from the center position of the curve. So we do need a value for the X, and then of course the standard deviation of the data set, and that's denoted by the Greek letter sigma, and it represents the population standard deviation. Now, this is not to be confused with the other sigma. This letter is called sigma. It's not to be confused with the other Greek letter sigma that we previously used for summation. The summation sigma is really the uppercase sigma in the Greek alphabet system, whereas the sigma that we are using for the standard deviation is the lowercase sigma in the Greek alphabet system. All right. Now, the formula for z is x minus mu in the numerator. So we take our specific x value, specific observation whose distance we are trying to find relative to the center point of the curve. And from that observation, we subtract the mean. Now, keep in mind that in a normal symmetric curve, the mean will be located at the center point, at the center, wherever it will be aligned to the peak point of the curve. All right. Again, that's because this is a symmetric curve. All right. That's where mu is located, and that's why we do x minus mu. And then we divide the numerator by sigma, or the population standard deviation, and once we do that, we get the distance of the observation in units standard deviation. Unit standard deviation means whether the value is 1 standard deviation above the mean, or 2 standard deviations below the mean, or 1.25 standard deviations above the mean. It gives positions between -3 and +3 relative to the center point of the curve of our distribution. Let's note some properties and facts about the z-scores. First of all, a z-score value is usually between -3 and +3. Secondly, if a z-score value of an observation is positive, it implies the observation is above the mean. If a z-score value of an observation is negative, it implies the observation is below the mean. And finally, a z-score value of 0 implies the observation is the same as the mean. So let me just demonstrate this here quickly with a figure of our normal curve. So here we have our symmetric distribution, and the mean will be located at the center point. So our mean will be located somewhere here. And it says here the z-score is usually between -3 and 3. Now, what will be the z-score value at the center point? Let's say the mean is 50. All right, the mean has a value of 50, and we want to know. So we always need the mean to calculate the z value, correct? Let's say our mu is 50, and we want to find the position of x whose value is 50. All right. And let's say the standard deviation is 5. Right. Now, if we were to calculate the z value, given these measures, how would we do that? Remember, z has a formula, the z value has a formula, x minus mu divided by sigma, correct? So if x is 50, then we have to do 50 minus 50, right? Mu is also 50 divided by 5. And 50 minus 50 is what? 0, correct? So z will have a value. Z will be equal to 0 divided by 5, and 0 divided by any number is a 0. So that means when x and mu have the same value, that means x is located at the center point. X and mu are the same values, and therefore the z value, its position from the center point, is 0, right? It is the same as the mean. Therefore, z-scores that tell us the position of a value from the center point will be 0 in that case. All right. The other z values would be +1, +2, and +3 on the right side of the center point. Right? So here it says a z-score value is usually between -3 and +3. Positive values 1, 2, 3 will be located to the right of the center point, and negative values, so -1, -2, and -3 will be located to the left of the mean. All right. So if we have a z value which is positive, that value will be on the right side of the center point of 0, and therefore it will tell us that the score or that observation is above the mean. If we have a negative value for z, then that tells us it is below the mean. It will be positioned somewhere to the left of 0. And this is like a number line, all right? So all values less than 0 will fall to the left. All values greater than 0 will fall to the right, right? And the z-score value of 0 implies the observation is the same as the mean, and that's what we verified. That's what we proved using this particular example and calculation. The center point where the mean is located will have a z value of 0. That means it tells us that the distance of a particular value is 0 if it is equal to the mean. Let's go through this example of calculating the z-score. It says here to calculate the z-score of the observation 55 for a data set with mean 64 and standard deviation 8. The formula to find the z-value is x minus mu divided by sigma. So we have to make sure that we have been given the values of all these variables, x, mu, and sigma. So let's go back to our question. It says calculate the z-score of the observation 55 with mean 64. So mu is going to be 64. Standard deviation denoted by sigma equals 8. So we write that there. And x is the particular observation whose z-score we are trying to find, whose position we are trying to find relative to the position of the mean, which is located at the center point of our diagram, of our curve, of our distribution. All right, so since we have all the values given and we have our formula, just go ahead and plug in the values. So 55 comes first, x minus mu. So 55 minus 64 divided by 8. Now 55 minus 64 is -9 divided by 8. And then we have a value, a z-score value of 1.125. But as you can see, something is not right with the final answer. We have -9 divided by 8, and we have a positive value here. So the minus sign is missing. So let's rewrite this with a negative sign. So the answer, the z value, is -1.125. All right, please make that correction. And I kind of purposely left it out but so students can catch the mistake and realize that the z-value should be negative whenever the x value is less than the mean. That means your z-value must be a negative value. If it isn't, then there has been some mistake somewhere in the calculations. All right. So z equals negative 1.125 means how would it look on our curve here? All right, so here's our normal curve, and the mean would be located right here, 64. And what is the distance of the mean from the center point? Is 0, right? The z-score of the center point is 0. In other words, the z-score of the mean is always going to be 0 in a z curve. All right. And then negative 1.125. Let's divide this horizontal line into what we call plus minus 3. So on the right hand side is going to be positive 1, positive 2, and positive 3. On the left hand side, it's going to be negative 1, negative 2, and negative 3. Correct? Negative 3. So where would negative 1.125 fall? It would fall somewhere. Of course, it will fall to the left because it's a value less than the mean. So it's going to be on the left side of 0. If negative 1 is here, then negative 1.125 is going to be a little bit to the left of negative 1, correct? So I'm going to mark it somewhere here maybe. All right, that's where negative 1.125 will be located. So what it says is 55 is negative 1.125 units away from the center position of the distribution. All right. Now you have seen this slide before when we were talking about the 3 standard deviation rule, also known as the empirical rule. But let's go over it one more time because this is something that we will need to apply in doing some assignments and calculations based on the z values. All right. So what the 3 standard deviations rule said was that almost all the observations in any data set lie within 3 standard deviations to either side of the mean. And not only that, the empirical rule also said that 68% of the observations will lie within plus minus 1 standard deviation. That means 68% of observations 68% of observations will be within a z-score value of plus minus 1. So if the center point is here, all right, if the center point is here and this represents negative 1 on the left hand side and positive 1 on the right hand side, then 68% of the observations will fit in between this area. All right. And then it says 95% of observations will lie within plus minus 2 z-scores. Plus minus 2 z-scores. That means it's going to be all this, including the plus minus 1. All right. So this area, all the frequencies within this area will be 95% of the observations. And finally, it says 99.7% of observations will lie between plus minus 3 standard deviations. So 99.7% is almost 100%, right? Will be within a z-score value of plus minus 3 or plus minus 3 standard deviation. So let's use a different color here. And so that means all this area, all all right, represents or encompasses 100%, approximately 100% of the observations. So that means all the observations will be included within minus 3 and plus 3 standard deviations. All right. Let's look at this example represented by this normal curve and try to understand it and draw some conclusions. All right. So look at here. We have this normal curve, which is a pretty symmetric curve. The mean is located at the center point where the peak of the curve is, and that's where the mean will be positioned. And looks like this is about test scores. All right. And then if we go down a little bit, it shows SAT scores and ACT scores, the standardized scores that colleges require sometimes from students for admission purposes. So that's what this diagram or this normal distribution is about. It says here normal curve and other equivalents. And along the horizontal line, we have not the actual values, not the actual scores, but the standard deviation values. So mean at the center will have a standard deviation of, or rather a z-score of 0, right? Now, as we go towards the right, the first one is plus 1 standard deviation. So this plus 1 is the z value. All right. Then we have plus 2 standard deviation. So plus 2 represents the z-score of a score that will fall in this region of the line. And then we have plus 3 standard deviation. On the left hand side, we have minus 1 standard deviation, minus 2 standard deviation, and minus 3 standard deviations. And the z-score will be only these minus 1, minus 2, and minus 3, and plus 1, plus 2, and plus 3 numbers. And look at how the distribution is shown over here. All right, remember we said within minus 1 and plus 1 standard deviation will be contained 68% of the observations. So on the left hand side of the mean, between 0 and negative 1, we have 34.13% of the observations. And on the right hand side, between 0 and plus 1, we have another 34.13%. Okay. Then between negative 2 and positive 2, we are expecting 95% of the observations to be contained. So we have 34.13. So let's just take the round it up instead of looking at it with the decimals. I'm just going to round it up, and so it's 34 plus 13, which is 47, and on this side 234 plus 13, 47, and with the decimal it'll be roughly 95%, correct? And then between minus 3 and plus 3 is another 2.14% added to the 95%. So 2.14% on the left hand side, 2.14% on the right hand side, added to the 95% would be roughly 99 point some percent. And outside of the minus 3 and plus 3 is a very, very small percentage, which is 0.13%. All right. So 0.13% on the left hand side, 0.13% on the right hand side, 0.26%. Okay. So over here they've shown the z-scores. This is the line demonstrating the z-score values. Then there is tan9, and we'll talk about percentile a little bit, but don't worry about the tan9s. This application is of SAT scores. So the mean SAT scores, this is the center point, right? The mean value is 500 of SAT scores. And then what can you say about the standard deviation? Just by looking at the values at one standard deviation, we can tell that the standard deviation is 100. Okay, if this is 500, the distance, the next value at one standard deviation is 600. So 600 minus 500 is 100. And let's do it this way. All right, we have z equals x minus mu divided by sigma, correct? So we see over here that 600 is at a z-score value of +1. So that means z is 1, x is 600, mu is 500 divided by, we don't know what sigma is, correct? So let's solve for sigma. The standard deviation is what we are interested in finding. So 1 equals 100 divided by sigma. Therefore, sigma is, all right, you can cross multiply over here. Sigma is equal to 100. That means standard deviation is 100. So if you know, if you are given the z value, if you are given the x value, if you're given the mean, then you can calculate your sigma. Likewise, if you're given the z value, you're given the mean, and you're given the standard deviation value, you can solve for x and find the observation. All right. So this is what this diagram or this slide is about, to make sure that we can interpret, understand what we learned so far on standard deviations, about the normal curve, about the z value, and the formula for the z value. All right. Now, I will have a worksheet up with solutions. I would want all of you to look at it, all right, view the solutions, and make sure that you understand how we work on questions related to the z values. All right.